this part, once you have given all these problems a try, you can continue the video to look at the solution for this. And for now you try problems, I'm going to just go ahead and jump into GeoGebra to actually solve the problems over here. And for each equation, I'm going to set the left side to be f and right side to be g. So in the first problem over here, I'm going to go ahead and delete all the previous information. So here for the first one, we have f of x equal to x over x minus 5. I forgot to put the equal sign, and that should be the equation we have. And for the right hand side, we have g of x, which is a constant. It's equal to 2 in this case, and we can find that these are the two graphs we got. And in this case, if we want to find the intersect, we can click on the graphs over here and get the intersect at 10, 2. So based on this, we can say the solution is 10 over here. The solution set is 10. And I'm going to attach the screenshot of this in the solution as well of this graph. And feel free to go through the process of checking your solution by plugging 10 into both sides. We can quickly do this verbally. If you plug 10 on the left, you'll have 10 over 10 minus 5. 10 minus 5 is 5, so 10 over 5 will be 2, which is equal to the right hand side, and also equal to the y-coordinate of the intersection. That's what we're looking for. And looking at part B, we can go ahead and put this in GeoGebra again. I'm going to delete these. Here I have the left hand side, f of x is equal to, or in this case f of t. I'm just going to be consistent with the variables that we are given. It's equal to, I'm trying to place it at a reasonable spot. And we will get the result of t plus 9 all over t squared plus 15t plus 54 over here. And this is our graph in dark. And the other side, we just have 0. So g of x is equal to 0 in this case. So we can see that when we're looking for the intersect, essentially we're looking for the y-intercept of our curve. That would be doing exactly the same thing. And now to find the intersect, and once you do so, I hope you have given it a try on your own already. If you try to find the intersect of these two curves, as I said, you're looking for the y-intercept, you will notice it is undefined. In this case, it is truly undefined because if you look at this graph of the rational function, you will notice there's indeed no x-intercept at all in this process. You can see this graph is getting closer and closer to the x-axis, but as you zoom in, you will notice that there's always going to be a little gap overall. And this is the first time we encounter a case of no solution for rational equations, and we can kind of talk about why this happens over here. So first of all, we can say there is no intersection. So when GeoGebra shows undefined, that just means they can't find an intersection over here. If you tried a bunch of times and still didn't find the points, in this case it means there's no intersection, and therefore there is no solution. Or you can say the solution is the empty set, if you want to use the set notation. And this is something we can actually show this happens with this particular problem. We can actually think about what we would do if we were to simplify this expression by hand a little bit. So we started off saying f of x, or f of t, in this case, is what we did on the left hand side. It's t plus 9 over t squared plus 15t plus 54. And when we want to simplify this, as we want to simplify any rational expression, we want to think about whether there's any factorization we can do. On the denominator, we can actually factor this further to be t plus 9 and t plus 6 over here. So when we have this type of problem, we said really the way of simplification was to cancel out any common factor. And as we cancel out the common factor, we're using the fact that t doesn't equal to -9. And therefore our equation, or our function, becomes 1 over t plus 6. And we still have the domain restriction of t doesn't equal to -6 in the final answer. But when we look at what we have for 1 over t plus 6, and essentially we're saying this expression is equal to what we started for f of t. And if I want to find where this f of t is equal to 0, it's equivalent to finding the 0 of this final result. And to find the 0, we said it's the same as finding the x-intercept. And to do this, I need the numerator to be equal to 0. But in this case, you can see this numerator can never be equal to 0. And that's the same reason we can look back to the original problem. We have t plus 9. And if we want numerator to be 0, we would need t plus 9 to be equal to 0. But we highlighted that t does not equal to -9. So t plus 9 doesn't equal to 0 ever. So because of this, we can't find any solution. So we would say, therefore, there is no solution. Or, yeah, for this equation, because our function has no x-intercept. This is a nice example to kind of think about. Because we're working with rational functions, there are naturally these domain restrictions, so we want to be extra careful. Even if we do seem to have some sort of equation to solve, we might have to rule out the solution that's making the numerator possibly 0. In this case, the only candidate is -9, and that's getting ruled out by the domain restriction. Now moving on to part C. We have this expression over here. I'm going to go ahead and plug both sides in again. So it's f of y in this case. So I think in GeoGebra it actually has trouble recognizing y as the input over here. So just to make things a little bit simpler, I'm going to use x, because we are in the xy coordinate plane, and by default y is considered as the output in the system. So I'm just going to change all the y to x over here. That way we can see a graph over here, and if you want, you can move things around just to see a better picture over here. Since we moved the screen a little bit earlier, this should be the center of the coordinate plane. And the other side, we had 1/5. So we still want to use x equal to 1 over 5. So that's what we get, and now we can try to find the intersect of these two over here. I don't know why I always have trouble finding the curve. Okay, there. In this case, we find the intersection is 5, 0.2. And therefore, we would have the solution being x equals 5. And you can see why the y-coordinate is equal to 0.2, because 0.2 is equal to 1/5. This is really the same as 1/5. And we should expect when we plug the x value in, we would get the same y value. In this case, the y value should always be 1/5 in order for this to work. So solution set is just 5 in this case. Again, feel free to go through this step of checking, but I'm going to go ahead and attach this graph over here just for reference. Lastly, we have part D, so just let me take a minute and plug everything into GeoGebra, and you will see this magically show up as a graph in GeoGebra. Alright, here we are. Now you can actually see the two graphs over here. These two are very interesting curves that we haven't encountered before, and you can see there are multiple branches. Overall, they're kind of intersecting at places over here. You can see there's an intersection here already just by looking at this part of the screen over here. And now to find the intersect, I'm going to go ahead and use the function here again. Here's my first curve, and here's my second curve. You will see that A is equal to this, and because there are multiple branches, we want to go ahead and choose A over here, or a curve over here, and a curve over here. Then we will find the other intersection in this case, which is equal to 5, negative 0.14 over here, and we can move around to make sure that we got all the intersections in this case. So seems like we only have 2 intersections because that's where the branches of the functions are intersecting. And once we do so, we will get to record these 2 intersection points. And here A is negative 1.25, comma 0.12, and B is negative 0.14. So there are 2 intersections. And once we find these 2 intersections, that means we also have 2 solutions over here. And we can say the solution set is again the x values, negative 1.25, comma 5 over here. And these are the graphs that we're looking at, and we have 2 results in this case. And here's a screenshot, and that's how we approach this type of problem when we're solving problems by graphing.